Okay, today we're going to be graphing tangent and cotangent. So first off, we're going to look at graphing y equals tangent x. We're just going to do basic tangent. As a reminder, tangent is sine over cosine. And remember, we cannot have 0 in the denominator. If you have 0 in the denominator, it is undefined. So graphing tangent will also have asymptotes. Our asymptotes will be everywhere that it makes this 0 in the denominator. So we need to know everywhere, where does cosine of what equals 0? Well, one of your asymptotes is going to be at pi over 2, because pi over 2 is 90 degrees. If you put in 90 degrees right here for x, cosine of 90 is 0, and that would make 0 in the denominator. So therefore, there's an asymptote at pi over 2. Remember, asymptotes are represented as a dashed line, which also means there'll be an asymptote at negative 90. There'll be an asymptote. Turns out that for tangent, your asymptotes are at every multiples of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, multiples of pi over 2. 3 pi over 2, that's 270 degrees. If you put 270 degrees in for x, cosine of 270 is 0, it would make that denominator 0. So therefore, there is an asymptote there. Okay, now, how do we graph tangent? Also, if you'll notice, well, I'll graph it first. So, graphing tangent. So, tangent, then let's just look at pi. If you put in pi for x, right here in this equation, or in here, tangent of 180 degrees is 0. Here, putting it in for sine, sine of 180 degrees is 0. 0 divided by anything is 0. So therefore, that would be 0. And then tangent is going to curve this way. So here at 2 pi also, 0, curve this way. And again, this is the way that I graph tangent and cotangent without having to plug numbers in, okay? I'm going to point out some easy ways to remember this. The one thing you have to memorize is that tangent starts on the right-hand side and goes towards the left. You do have to memorize that. And remember, your lines will go towards the asymptotes but never cross them. The asymptotes are boundaries. So here's some easy things to remember. If you can write your asymptotes first, and the one thing to notice is tangent, this runs a full cycle. Okay, it runs a full cycle and then it repeats itself. So the period, the normal period for tangent is pi. If you could see how it's 4 tick marks, 1, 2, 3, 4, that's the distance of pi. It runs a full period in a cycle of pi and then it repeats itself. Okay, so once you get the asymptotes drawn, then your basic tangent where it crosses the x-axis will be right in the dead center of these asymptotes. Okay, this tick mark is in the middle of these asymptotes. This is in the middle of these asymptotes. This is in the center of these asymptotes. So once you get your asymptotes drawn, usually a lot of times it's easier to draw your center point because it's going to be halfway in between the asymptotes. Then if you just remember, tangent starts up here to the right and then it goes down toward the left. So that is your basic tangent. Again, these points here, 0. Sine of 0 is 0. So and 0 divided by anything is 0. So when your numerator is 0, we'll create these points. When your denominator is 0, create your asymptotes for tangent. Okay? Okay, now we're going to be graphing basic cotangent. And as a reminder, cotangent is cosine over sine. So with cotangent, still we cannot have the denominator be 0. So we need to know where does sine of whatever equal 0. So for sine, at 0, if you put in 0 for x, 0 degrees, sine of 0 degrees is 0. Pi, 180 degrees. If you put in 180 degrees for x, sine of 180 degrees is 0. So it turns out for cotangent, your asymptotes are going to be every multiples of pi. 0, pi, 2 pi, 3 pi, etc. So 0, sine of 0 is 0, which makes that denominator 0. Pi, 180 degrees, sine of 180 degrees is 0, which makes that denominator 0. So for cotangent, your asymptotes are every multiples of pi. 0, pi, 2 pi, 3 pi, 4 pi, etc. Just as tangent, the period it runs its cycle in pi, same as cotangent. So you can see that, this is from here to here is going to run one whole cycle. And then here it's going to repeat itself. So again, with cotangent, you can almost just say, what's the halfway point between here and here? Well, the halfway point is pi over 2. So that's where your curve is going to change directions from one way to the other. Same here. Here's the halfway point. And here, 90 degrees. If you put in 90 for x, turns out in the numerator, cosine of 90 is 0. 0 divided by anything is 0. So that's where you'll be crossing the x-axis. And cotangent goes the opposite way of tangent. So it'll be starting here to the left, and then go down and change directions down to the right. Here, and then change directions down to the right. And again, your curve goes toward the asymptotes and gets closer and closer and closer, but never crosses them. The asymptote is a boundary. The one thing I also want to point out in this lesson is, now that we have basic tangent and basic cotangent, we'll now start going to other equations where we have a period change, an amplitude change, a translation, or a phase shift. Here on your amplitude change, it's not really, it will affect your curve, but you can sort of ignore it for these problems. What your amplitude change does, remember amplitude determines how tall or short, but since cotangent and tangent are kind of sideways, it basically determines the width going this way. So it's going to determine your steepness or your width. How steep is it going down, or does it come out wider and then go down? So for purposes of my class, you can, or for the purposes of even high school trigonometry, you can almost just kind of estimate it, because since I'm only plotting this one point for cotangent and tangent, I'm not plotting any other points, then you can just kind of estimate the steepness of the amplitude. So now we're going to be looking at 25b2. So we're doing cotangent. So you need to know basic cotangent first. Here in this equation we have an amplitude change, and then we have a translation. This is a positive translation, so it's going to be shifting up. Here there's an amplitude change. Again, this affects the steepness of the curve. How wide, or how steep is it going up or down. So again, I just try to draw all mine just from an estimation, so all of mine curves look the same. I usually don't take the amplitude into effect because I'm just estimating, but just to tell you, that's what the amplitude does. So really for this, I'm just going to draw basic cotangent, and then I'm going to shift up 1. The only time your asymptotes will change is when you have a phase shift. When you have a translation up or down, your asymptotes don't move. So the only time your asymptotes move is if you have a period change in front of your x, or if you have a phase shift. For all the problems in this course, there's not going to be any period changes. So the only time your asymptotes will shift in this course is when you have a phase shift. So on that note, since there's no phase shift, then my asymptotes are not going to change. So for cotangent, for this problem, your asymptote is going to be at 0, and then multiples of pi. Pi, 2 pi, and it's really only necessary to draw one period, but I'll draw 2. And then here is your, I'm going to draw in black, this is your basic cotangent. Basic cotangent is here and here, and I'm going to draw it as a dashed line because this is not your final answer. And again, I'm not really taking into account the amplitude. I'm just trying to estimate. All I'm doing is just trying to estimate. I'm just drawing an estimated graph. This is basic cotangent, but I have a translation of 1/2. So all I need to do is I'm going to take this main point that I graph. I just basically graph one point for cotangent and tangent. So I'm going to take this one point and shift it up 1/2. Take this point and shift it up 1/2. And then, so now cotangent will look the same way. It'll be this whole graph just shifted up 1/2. So this is the point where I will change from one direction to the other direction. So then, kind of look like this, and it'll change right here to go down. And then here, and it'll change right here to go down. So everything in blue is my final answer. And I would label your final answers. Okay, now we're looking at 25C2. Just as a reminder, I don't work these problems out the way the book does. The book is going to put different values in for X and then find the value for Y and make like an XY table and then plot those points. The way that I work them is to graph basic tangent and then I move everything from there. And with tangent and cotangent, I pretty much graph one point and then I shift that one point around. Alright, here, there's no amplitude change and there's no period change. There's no number in front, there's no coefficient in front of the tangent and there's no coefficient in front of the X. So this is a phase shift, this is a translation. We will be translating up, because that's a positive, 1/2. And then as a reminder, this phase shift would be X minus a negative pi over 4. Your equation is a minus, your formula has a minus sign there, so in order to get a positive, you have to subtract a negative. So this negative right there tells you you're shifting to the left. When this is a positive, you shift to the left to make it a minus, a negative. So we are shifting to the left, pi over 4. Okay? On your graph, you have to know what each tick mark stands for. So each tick mark does represent pi over 4. This is pi over 2, so this is pi over 4. Remember, for basic tangent, your asymptotes were at multiples of pi over 2. So that means your asymptotes were at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so forth. So since there's a phase shift, you need to shift your asymptotes because everything will shift. Your whole thing shifts pi over 4 to the left. Okay? Asymptotes and everything. So normally my asymptote for basic tangent would be at pi over 2, but I need to shift it pi over 4 to the left. So one tick mark to the left would be shifting pi over 4 to the left. So my new asymptote is right there. My original one would have been there. Okay? So let's go to negative pi over 2. That would have been the original asymptote, but now I need to shift negative pi over 4. Pi over 4 is one tick mark, so one tick mark to the left puts me right there. Okay, let's go over here at 3 pi over 2. This would be where my original asymptote is for basic tangent, but I need to go to the left, one tick mark, which is left, pi over 4. So that would be there. And you can go on to do one more if you want, one more cycle, but I'm just going to do these two right here. So, okay, basic tangent. Where would basic tangent be within here? So, according to my phase shift, all I have to do is go halfway in between these, okay? Halfway in between my asymptotes is right here, okay? So normally that point would be right there, same here. Well, it would have been right there originally, but now my new is 1, 2, 3, 4, okay? 1, 2. My new point of where I changed directions is there. Okay, so that took into account our phase shift. Now I need to take into account translating up 1/2. Okay, so now I need to take that point. Again, once you have your asymptotes, this point of where your graph changes direction is going to be halfway in between your asymptotes. If that's the one thing you remember, halfway in between your asymptotes. So I need to translate up 1/2. So now I need to take this point and translate up 1. I'm sorry, up 1/2. That's really in between 0 and 1, so that's at 1/2. So I'll take this up and translate 1/2. That's at 1/2 right there, right there. So now tangent. Which way does tangent go? Tangent starts at the right and then changes direction and go down to the left. So tangent starts up here and then just goes here and then down to the left. Same here, and it's going to change direction at that point, that one point that we're graphing. So that blue line is your final answer. Again, for tangent and cotangent, I only graph the one point of where the curve changes direction, and then I just estimate everything from there. In my opinion, for this course, that is enough to understand what tangent and cotangent look like. Okay, now let's look at 25D2. So cotangent, so we've got to know the basic cotangent graph. We do have an amplitude change, but again, the amplitude has to do, changes the steepness of the curve. And since I'm just estimating the whole rest of the curve, I usually just don't take that into account. This is a phase shift. Remember, it's got to be in a subtraction sign there, so I'd be subtracting a negative. So again, this says we're shifting to the left. And then we're going to be translating up 1. So pretty similar to the problem that we just did, except for it's cotangent. So you just have to know which way the curve is going. Whenever I'm doing cotangent and tangent, I have asymptotes, I always do my phase shift first. So that way I can shift my asymptotes. Since there's a phase shift, your asymptotes have to shift as well. For cotangent, your asymptotes are on the 0 and the multiples of pi. 0, pi, 2 pi, 3 pi, 4 pi for basic cotangent. So if my asymptote was at 0, but now I want to shift over to the left, pi over 4. Pi over 4 is 1 tick mark. So now my new asymptote will be right there. The next asymptote was at pi for basic cotangent, but now I need to shift to the left 1 tick mark. So my new asymptote will be right there. Let's say I go over to 2 pi. There would have been an asymptote there for basic cotangent, but now I need to shift to the left, pi over 4, which is 1 tick mark. So these are my new asymptotes for this equation. So for the one point that we're graphing, all you have to do is now put your point in the middle of those, in the center of those asymptotes. So the center of this will be 1, 2, 3, 4, 1, 2, right there. Center of this one, right there. If you had basic cotangent, you would be changing, your graph would be changing directions at the x-axis, but we have to take into account this translation. So we need to translate this point up 1. So when we shifted our asymptotes, that point automatically got shifted over with the shift of our asymptotes. So it already automatically got taken into account. Now we need to translate up 1. Positive means up, so take this up and put it up at 1. Take this up and put it up at 1. And now cotangent starts from the left and then changes direction at that point and then goes down to the right. This didn't look so pretty right there. It would have been more like this. I'm trying to draw over bumps on a wall. Here, change directions, then go down toward the asymptote. Again, I'm estimating. I know that this point is exact. Everything else I'm estimating the curve.